Hey everybody, welcome back. This is Tech Junior's Tutorials. My name is Lee Warwick Jr. and we're going to be talking about Advent of Code. So today is day 19. I just finished day 17, so we're going to be talking about 17. 17 was another intcode problem. So running on the same intcode computer that we made way back in, or finished way back in day 9, I believe. So pretty interesting one, some good visualizations, so let's check it out. So, like I said, today's day 19, but we're going to talk about day 17. Real quick before we start, day 18 looks to be a real bear of a problem. So it's another maze problem, and here's the puzzle input. It's like a giant double maze. So I don't know how long it's going to take me to do this one, but if you look at this cool visualization that I found, this fellow on Twitter, Moritz VD She, from the Netherlands. Nice guy, has been following all these videos, and when I've been posting them on Twitter and stuff, he's got an actual visualization of all these problems. So if we look at Advent of Code for this year, I know I made a lot of complaints about day 16 and how hard it was. It looks like day 16 part 2, which is the yellow, is part 2. I believe these are the top 100 people, or like everybody on the leaderboard for Advent of Code. And it's like the lower the number, that's like person in position 1. And then up here would be like person in position 100. So the grouping of these is like how long the top folks are taking to get the answers. So the higher the graph, basically, the longer it's taking people on average. And it looks like for day 16, like that was a pretty tough day, the toughest up to that point. But now 18 looks to be an absolute nightmare, possibly the hardest one for this year. So I bring all this up when we're talking about day 17, just because I don't know how long it's going to take me to get day 18. It could take me, who knows? Could take me hours, could take me a couple days. And again, the closer we get to Christmas, the harder it is to set time aside to do these. So hopefully I'll get caught up, but it doesn't look like it from day 18. So we'll see how that one goes. But let's talk about day 17, which I did get, thankfully. So this one is another intcode one like we talked about, so we won't go over that and waste any time on that. But basically what they tell you is that you've got some kind of robot. It's got some kind of path that it's traveling, and it can't go off the path, otherwise it'll like fly off into space. But basically, intcode is going to give us ASCII values, and we're going to convert those into characters. And when we give instructions to the intcode program, we're going to give them as numbers, the numbers being actual ASCII code. So if we get a 35 from the intcode program, that means we're getting a hashtag. If we want to give it a hashtag, we have to give it the number 35. From there, it tells us we've got some kind of map that looks like this. The caret or the arrow is the robot and what direction it's facing. So it could be like up, down, left, or right. And basically for part 1, it's just kind of checking to see if our program is working and if we can actually visualize this thing. It just wants us to find the intersections. So hashtags are the path. An intersection is any time where there are a cross of these hashtags. So they have a good visualization here. We don't care about the edges. So like that doesn't count. That doesn't count. Only actual 4-way intersections. So in this one, there's only 4. And then it says we're going to take some kind of alignment parameter, but it's actually the X and Y values for this if you consider this point 0, 0. So this circle would be 1, 2, 1, 2. So they say units from the left and units from the top. So they're, again, counting this as 0, 0. Just like you would for pixels if you were doing image manipulation or working with HTML5 canvas or something like that. Top left is always 0. So it's really nice that we can do that and not have to worry about some kind of weird conversion. So they want you to take the XY coordinates and multiply them together. for each one of these intersections, and then just add those values together. And that's pretty much it for part 1. So they say in this example, like if you multiply all the coordinates and add them up, you'd get 76. And then they want to know about what is the alignment parameters for your program. So if we look at my code, I've got get inputs and int code are both part of my int code program solution from previous days. So the only new code is coming down here. So first thing I did was just see like, okay, is my int code program going to run properly and what am I going to get? So they didn't talk about any kind of input for this. So I went ahead and said like, okay, I'm going to pass a function. And if they do ask for an input, go ahead and throw an error. Otherwise, I've got a little outputter function that's just going to visualize this for us. And what this does is there's just a string. And basically, I'm going to look for new line characters. So every time they throw us a new line, I'm going to print the current string. You don't have to do it like this. You could have just gotten one giant string. But I didn't know. I don't know. I guess really you're not really worried about when int code finishes. It's just going to print the strings until it stops running. So if you do that, what you'll see is something like this. So this is our total path and all of our intersections and whatnot. It's a little hard to read like this. This doesn't tell us where the intersections are. It just visualizes the actual int code program running. So I was going to need more than that. You could actually count this and just do the math on a pencil and paper, which I thought was kind of weird. I thought about doing that just to get it over with, but I didn't know if we would need that part for part 2. So what I ended up doing was I scrapped that. I was glad that it worked, but what I ended up rolling with for solution to part 1 was this set of code, which is a little bit bigger, but most of it is in the meat of it, at least, is this function here. Well, it's not really a function, it's just some nested for loops. But instead of just printing the outputs, I'm going to store them in a grid. So I'm going to make my outer list basically my y values, and then my it's going to be a 2D list. So the outer list is going to be rows, and the rows are going to be my x values. So basically I say like make the current row just a blank list, and as I loop through, if I ever get a new line character, that means drop down to a new row. So if I get a new line, I'm going to go ahead and add in my current row to my grid, and then create a new current row parameter. So that, again, just creates like a big 2D list of all these values. And then to print them, this is a little bit more complicated. What I ended up doing was I needed to look at some rulers for part 2. So this is more complicated than it needs to be. You could get away with just looping over the rows and joining them on like a space, and that would print it just fine. But for my actual logic to calculate the points, I loop through the grid, and at the very end I print it. But as I'm looping through that 2D list, I'm using y as my outer loop, x is my inner loop, and I'm looping not over 0 to the end. I'm going from 1 to the 1 minus the end. So the reason that I'm doing that is if we look at this output again, I'm going to be checking above and below and to the left and right of each one of these hashtag values. And I don't want to try and go outside of the grid to look right or up, basically. So I want to stay like within this space instead of going above. We'll blow this up a little bit. Instead of going above here and looking like here and checking above, that would put me outside of my bounds. I want to look here and look above, because it's not actually possible to be in an intersection here or on this row, but that could be an intersection. That could not. So that's kind of what I'm doing with this slightly smaller grid that I'm looping over. So I loop over my x and y values, and then I create some, or basically look up whatever is stored there for above, below, right, and left of my current point. And then I say, hey, if I've got hashtags in all those spots plus my current spot, that means I'm at an intersection. Change that to a 0, just like in the examples. Multiply the x and y and add those to a total that I've got up here as 0. And then that's it. Just print the grid. Sorry, I've got this cold. But if we look at that, see what we get. So I'll have to make this a little bit smaller and run it again. There we go. So this gives us all of the intersections, plus a nice little ruler on the left and right and top and bottom. So I just added some spaces and counted over my indices whenever I was looping. In my print grid function. So if you look at this, I'm just tracking like the index in a couple spots. So I'm creating like a row ruler, which would go on the top and bottom. So you can see I print that at the top and bottom. And then in the middle, I prepend the row number. So these are like column numbers at top and bottom, and then row numbers at top and bottom, column numbers on the side. So the column numbers, you can see if we blow this up, we've got a grid that goes from 0 to 40 and from 0 to 48. And I had to play with that a little bit just to get everything to pretty print nicely. But once I did, it made things a lot easier for part 2. So you can see I get at the end 6,212 for all of those alignment parameters, and that's the value. Part 2 is the tricky part. So for part 2, they're saying like your robot's actually going to travel this path. So if it starts here, it's going to actually move along this thing. And as it's moving along the path, what they want to know is, let's say this is the path that you've got. They want to know, like, how long does it take to travel what is basically the entire path? And there's a couple of caveats that they add in. So first, they say you're going to communicate back to the program with ASCII values. So, and you have to give it the commas and everything. So you're going to give it like R, comma, 8, comma, R, comma, 8, comma, all converted to ASCII numbers or char codes, or however you want to look at it. So they say, like, if you're going to give it A, comma, B, comma, C, that's going to be 65 for A, B is 44, C is 66. I'm sorry, A is 65, comma is 44, B is 66, comma is 44, C is 67, so on and so forth. And then when you're done with that instruction, you're going to pass a new line character. So what they say is you've got some kind of arbitrary memory limit, which is a little bit silly for your robot. And they say you could just pass it one giant string of instructions to go like up, down, left, right, and however long and how far. But they say that you can't do that. You have to break it up into repeatable instructions. So like they give you a set of 3 functions you can pass. And those functions are basically subsets of commands. So like, here's a little example. If function A is right 8, B is right 4, right 8, and C is L left 6, left 2, you could give it any combination of A, B, and C as long as it covers the entire area. Aside from that, I know this is getting kind of crazy, but so you've got to give it those values basically as like one ASCII code at a time. So you give it the main routine. So you're going to give it all that plus a 10, right? So you're basically giving it that list, and then your A function, your B function, and your C function. So you're going to add all this into one giant list, and then give it these values as it asks for it one at a time. You're going to give it 66, 44, 66, 310, 82, 44, 56, 44, all the way, and then at the very end, you give it one final command, which is like a yes or no. Somewhere in here. They talk about it. Oh, yeah. So you can get a continuous video feed, which means they're going to toss you the output values as you're going. So it will output the entire map, just like it did for part 1, if you pass it a yes. And if not, it'll just give you the final answer. And the final answer is, it says, like, while it's traveling this path, it's going to vacuum up space dust, and it's going to give you some value that is way bigger than ASCII. And that value is going to be your puzzle answer, which for me was 1,016,000 something. So that's kind of crazy. That's a lot of junk to parse, really. And the meat of this one is like, how do you get repeatable instructions to do this? So some people, I think, thought of this as like a algorithm problem, like how should I travel this path to get my robot to auto find the set of functions that it needs. But forget that. There's no freaking way. So that's where I ended up using this ruler and visualization for this. I wanted to know, like, okay, if I go that way, and then that way, and then this way, like, is that a repeated pattern? Because if you look at this, like this area up here in the top right, that square in this little box kind of looks like this square over here in this little box. This pattern where you start is the same command as this one up here. So it looks like it's very kind of like symmetrical, as if you had a image and you rotated it on top of itself or something whenever you're looking at this path. So I figured it'd probably be a lot faster to just visualize this and map it out manually by hand than actually program something like that. That did some kind of pathfinding, and like if it fell off into space or some junk, start over. That would be a way more complex problem to solve. So I didn't do that. So if we look at my code for part 2, we'll cover up all these ink code program stuff. So here's my whole solution. Basically, what I do is I have a list exploded out from a string. So here's my string of commands for the movement patterns. Here is function A, here's function B, here's function C, and then I pass it at the very end. Do I want it to visualize it? Yes, I do. And then I just add those strings together. Or actually, they're lists. So as I make the string, I explode it out into a list. So that splits it into comma-separated values in Python. So I get one giant list, and then I just reverse it. And then for my input function, I just pop off the list. So that would give me A first, and then comma, then A, then comma, then B, then comma. Finally, I would give the Y and the new line character. And as I pop those things off the list, I use the ORD function in Python to convert that string value, or that string character, into an ASCII value. So A becomes 65, new line becomes 10, so on and so forth. Then for my output code, most of this is just to visualize it. Like, all this stuff is purely for visualization. The actual answer comes out of this, and I just guessed. I was like, I think ASCII codes go up to like 200 something. Or, man, it may not even be that high. I thought it was like 255 or something for ASCII just off the top of my head, so I figured if it's way bigger than ASCII, it's probably like in the thousands or more. So just check for if it's above 999, which I just picked kind of arbitrarily. And that ended up working. So I haven't even looked up ASCII. If you know what it is, throw it in the comments, I guess. So to visualize this thing, I've got an output string, and that is going to be like the entire map. So I say, like, if I've hit a new line, count that as a line, and then for each value that I get, concatenate that onto that output string, which will give me the entire map at the end. And then at the very beginning, they throw you a visualization where they say, like, here's your movement function, here's your function A, here's your B, here's your C. But it didn't actually work for me, so I just basically programmed around it and said, if I printed 48 lines, which would be the map plus that stuff, go ahead and visualize the map, print the whole thing, and then start over at 0. Otherwise, it prints the entire map, which is, I think, 41 tall. 41 tall with the new line at the end. So that makes it, yeah. So I add 1 for each line, and when I hit 42, meaning that I've hit that 42nd line, then that means it's time to visualize a new map. So clear out my output string so I can start collecting all of the outputs again to then print. So if we visualize that, we'll get a nice GIF-able output where you can see like the robot following the path, which is cool. But how did I actually solve the problem? How did I actually solve these inputs? Well, I did it the manual way. So if we look at this, I've got my actual stuff that I use to do this. So this is my hand-drawn with my mouse, screenshotted with the rulers and figured out like what all these lines were and how long they were. So I'm looking in the middle here, looking up. I want to turn left and then move 10 places. So like my ruler lines really helped for that. So left 10, right 8, right 8. That's repeated right away. Left 10, right 8, right 8. So I knew that that was probably a function I was going to use. And then I saw this pattern, left 10, left 12, right 8. That seemed like it would be a repeated one because I see it again down here. And then the orange one gave me the new pattern. So once I saw this second green line happen, I was like, okay, this must be my patterns. It's the red, the green, and the orange. And that worked all the way until I got to this blue line where I was like, oh gosh, now I've got R10, L12, R10, and that's not in any of these patterns anywhere. So I thought. So I figured, okay, maybe that'll work. So I'll do A is L10, R8, R8, L10, R8, R8. B will be 1, 2, 3, 4, 5, 6, 7. 7 commands long. And then C will just be this one-time use thing. And I tried that, and it printed out an error message as the output of the intcode program, and it was like, you've run out of memory. So they actually coded the intcode to say you've run out of memory, which is pretty impressive. And it's like, oh, your output can only be so long, basically. So what happened was in the instructions, they say that your computer has only so much memory, and it says that each function can contain at most 20 characters. So if we look at my final solution in here, basically I had to rework it, but for B, because B was so long, looking at this map, you can see like it is 7 commands, but that means you've got each character is its own like memory value. So L10 is 3 spots, so that's like 3, 3, 2, that's 8, plus 12 is 20. But you also have to take into account the commas in between those values. So with the commas, it ended up going over the 20. And so then I was like, gosh, I need to rework this. And then I saw at the very end, this R10, L12, R10 is the same as this the back half of this orange value, R10, L12, R10. So I had to redraw this. And basically what I got from there was this. So if I do split this up a little differently and have the yellow line be L10 R or L10 L12 R8 R10. That's like a combo of the previous one. Basically, I just redivided these segments. So I've got now the red segment, the yellow segment, and the green segment. These are all under the limit of 20 characters for each function. So that's what I ended up going with. And you can see that's what I've got here in my actual output. So that's pretty much all there is to this one. We'll run it because it's kind of cool looking. So let's run 2. So you can see it actually, because I did like that clear screen after I get the certain amount of outputted lines, you can actually visualize this and watch it playing the video of the robot tracking this entire path, which I thought was pretty cool. So I really like that. I'm a sucker for visualizing all these ASCII like terminal things, as you can tell probably at this point. I love taking GIFs of these and posting them. Almost there. So this obviously runs a lot faster if you turn the video off. Basically, if you turn the video off, it doesn't output anything except for the very final value, which is greater than 1,000, so it'll actually just print that thing. So we're almost there, getting ready to hit the end. A couple more turns. And done. So there we go. Dust collected, 1,016,741, which is my output for the day. And if you're curious, this does actually work if you tell it not to do the video. So if we do that, it will just output actually the final screen. So if you do that, you kind of saw for a second there, yeah, it printed out my functions. So you can see main function ABC and then continuous video feed. It's got like question marks, so it didn't actually print. I don't know if it was supposed to like print out a yes or a no, or like what my actual input was or something like that. It just prints blank, but so I don't know if that's something that I did or they did. Who knows? But you get the output here where we started here. Now you can see the robot is actually in its final spot there, and it outputs the dust collected. So that's all we needed for this one. Pretty fun challenge. There's no way I would have coded like some kind of pathfinding algorithm to do all that stuff programmatically. That would be absolutely nightmarish. And this is probably the first one that I've actually solved on like paper, more or less, and then just kind of coded the instructions. So that was kind of an interesting thing to come across in doing these, but yeah, it was still an enjoyable puzzle, I think. Not really the best puzzle. It was just kind of like sit down and do the work and figure out the pattern. But the robot following the path and everything is super awesome. So I love that part. That's always really fun. And the only part I'm looking forward to for day 18 is being able to hopefully visualize some of the pathfinding that I'll have to do to get to all those doors and keys and stuff. So hopefully I'm able to solve that one. But that's all I've got for day 17. I'm going to get to work on day 18 and see how that goes. Like, subscribe, follow, all the good stuff. Let me know how you're doing in the comments, and I will see you for the next day.